right, let's review. Here we go. Oh, sorry. All right, so the quiz itself has 13 questions. And of those 13 questions, 3 are multiple choice. And there are 8 matching. Just to do something weird. And of course, the rest are just like regular. Whatever that means. So the first one, 3 more polar coordinates, 260. The angle is really the tricky part. So if you think about where 60 degrees is, so this is going the short way. You could also get to 60 degrees by going down and around. So that would be a negative angle. So if we kept it at 2, negative 300. Then you have the type of angle that has a negative radius, not the negative angle, but has a negative radius. And then you have to get to that angle 2 ways. So I know it's difficult without the polar grid. So if you need to look at another polar grid, like there's some below, use those. So basically, if this is 180 degrees, we are 60 degrees beyond 180. That puts us at 240. So there are 2 ways, obviously, to get to 240 this way, which will give you 240. So I have negative 2, 240. The negative 2 will shoot it back through the pole. And then, of course, I have to get to the 240 going this way in the negative angle way. And that will be a negative 120 degrees. And, of course, the negative 2. There are 2 ways to do number 2. You can use the second angle or second apps button on your calculator and look for where it says, rectangular to polar, R to P. You have to do one for R and one for theta. Or you could use the formulas, which you will be given the formulas. So R is equal to the square root of x squared plus y squared. And of course, theta is the inverse tangent of y over x. You could use either one of those. If you do the x squared plus y squared version, you'll have the square root of 149. That's 7 squared plus 10 squared, which is 12.21. Now be careful, you want to make sure that your angle is correct. If you think about the point negative 710, we're here. So you want a second quadrant angle. So depending on what you do, if you put it in the calculator with the buttons or if you put it in the calculator with the inverse tangent, either way, you should end up with a second quadrant angle. I would be careful if you get a negative angle. Also be careful if you get, a negative acute angle, something like that. You want to make sure you adjust it correctly to put it in the right quadrant. And if you do this, you get 124.99 degrees. To say 2 decimal places, so then you want to write it as a point. 12.21 and 124.99. Now another answer is to use the negative radius, and then this is a much harder answer than the negative angle, which would, I don't know why I have negative 55.01. Oh yeah, because it would put us here and then shoot us back through that way. So that's why negative 55.01. It's a much harder answer to come up with. You will have to do some graphing. It says to graph each of these and then write the rectangular form. The idea being, once you have the picture, the rectangular form will be kind of easy to come up with from the picture. So if you think about what negative 5 sine theta is, this is sine would be on the y-axis, which I know we don't really have, but the diameter, this is your diameter, is 5. And it does fit on the grid. So then you can tell that your radius, of course, would be 2.5. So our center is at 0, negative 2.5, and radius is 2.5. Writing the equation might be easier than graphing the problem. You can put it in the calculator. It'd be nice if we had some actual points to plot. This is right around here and here. And then, of course, this is a circle. The rectangular form of this circle is x squared plus y plus 2.5 squared is equal to 2.5 squared, which is 6.25. Please don't leave a number just squared. Please actually write it. Theta equals 150. Here's a 180. You can tell by the number of lines, these count by 15, so 150 is right here. So we would be along this line. Now the rectangular form of this, you may not be able to just look at it and write. So if you start with theta equals 150, then you take the tangent of both sides. Tangent of theta equals tangent of 150. In that quadrant, the tangent is negative. Tangent of theta is y over x, and the tangent of 150 is negative radical 3 over 3. Cross multiply. 3y equals negative x radical 3. We are multiplying. Do not turn that into a subtracting problem. And of course, you want to write this as y equals, please. So y equals negative x radical 3 over 3. And for r equals 3, this will be the third radius out. 1, 2, 3. And all of the angles will put you right on there. So you're dealing with a circle of center 0, 0. With a radius of 3, of course. So that's x squared plus y squared equals 9. So those are all the simplest versions of circles and lines. Then, as you know, we have more complicated versions. The rectangular form means no r, no theta, no words, just all x's and y's. For number 6, you would multiply both sides by r, because you want to kind of force the issue to have the r cosine theta and the r sine theta, and that's how you would accomplish that. So this is r squared equals 5r cosine theta plus 6r sine theta. Well, r squared is x squared plus y squared, and 5r cosine theta is going to be 5x and 6y. Now you want to put the families of letters together. So it's going to be x squared minus 5x. We're going to complete the square there. Plus y squared minus 6y. We'll complete the square there. And then those same numbers will be on the other side. Half of 5 is 2.5, and 2.5 squared is 6.25. So that's going to get added to both sides. Half of 6 is 3, and 3 squared is 9, and that gets added to both sides. So this is going to be the variable. The first sign, the number we squared, 2.5. Variable, which is y minus 3, quantity squared. And on the right-hand side, 15.25. All right, so for number 7, we really don't want secant. We want sine or cosine. So r is equal to negative 4 over cosine of theta. And now you cross multiply. So negative 4 is equal to r cosine theta. And just that fast, negative 4 is equal to x. And that one is finished. For number 8, it's set up and ready to go. We're just going to cross multiply. So negative 3, make sure you distribute. The r is going to go where you need it. To r cosine theta minus 4r sine theta. And of course now we take out the r cosine and make that an x. So we get negative 3 equals to x minus 4y. And you can leave it like this. You do not need to solve it for y. This one you do need to solve for y because it's a little bit more simple. For this where the theta equals, please solve it for y, but these other ones you don't have to. Now we're going to go the other direction, writing the polar form. So now we want the r and the theta. So y is the same as r sine theta. And remember, you're trying to get it to be r equals. Focus on that. Do what it takes to make it r equals. We're going to divide both sides by the sine of theta to get that r by itself. And so we get r equals. Now we don't really want the sign on the bottom, so we're going to bring this out. So this is negative 8 cosecant theta. And it's done. X is the same thing as r cosine theta, 3r cosine theta, plus 5 r sine theta. And of course the 4 is a plane 4. Again, to sort of force the issue to have the letter r written once, this means you're going to factor it. So we get 3 cosine theta plus 5 sine theta. And now we have the letter r written once, and to isolate that letter r, we just divide by this entire quantity, and you get r equals 4 over 3 cosine theta plus 5 sine theta. The question, so your answer, or the answer for number 10, looks very similar to the question from number 8, and so you can tell that that is allowed. You're going to be asked for the names of the graphs, which of course you have your calculator. So if you don't know the pattern, put it in the calculator and take a look at the picture. Make sure that you do zoom decimal or zoom in if you can't quite see the picture clearly. So this one is asking for the symmetry and the name. Multiplication with just a plain theta makes a circle. The fact that it's cosine makes it symmetry with the x-axis. Addition and subtraction makes a limacon or a cardioid. Because they're different, this is a limacon. You do not have to specify limacon with a loop or limacon without a loop. If you're just asked for the name in the matching, you may see that in the matching, but you can use your calculator to do those. And of course, because it's sine, this is y-axis. I almost wrote y sine. When the numbers match, it's a cardioid, even though we have a minus in front. And this, of course, cosine is just x-axis. Now, when there's a number in front of theta, this creates a rose. And if it's an even number in front of the theta, they have symmetry with the x and the y-axis. Okay, again, we're adding two different numbers. This is a limacon. And because it's the y-axis, or because it's sine, it's the y-axis. And multiplying again is a rose, but it's an odd number of petals, so we're only going to have the y-axis. You are going to have to do what's here in 17 and 18. Go backwards from a picture to the equation. So I really want to know that you know these patterns, and you'll have your calculator. The best way is to make a guess and graph it, or use some of these other ones. There's plenty of examples just on this page alone. There's examples everywhere. This is a cardioid, and a cardioid means that A equals B. It is down, so it's by the negative number, so we know we're going to have a subtraction sign. So we know it's going to be R equals, it's a 4, so in order to make A equals B, so A plus B has to equal 4, and A has to equal B, so they're both 2. So I know I have a 2, I know I have a minus sign, I have a 2. Because it's on the y-axis, it's going to be sine. Now, what is unclear is this plus or is this minus? You cannot tell. You can put them in the calculator to tell, but I think you get the same graph if it's plus 2 or minus 2. So it doesn't matter if you have a plus or a minus there. I have a plus or minus. You can choose. I'm going to just write plus. So here we have a rose with an odd number of petals. So R equals, it's symmetry only with the y. So we know we have sine, and because it has 3 petals, we know this is 3 theta. Now the length of each petal, which you can see right here in this downward petal, is a 4, and that's your first number. But what is a little bit unclear is if it's positive or negative, and you can have either one again. And then finally, your graphs. Work smart. You don't have to plot a million points. You don't even have to plot a lot of points, really. You also do not have to go from calculator to point. So what I mean by that is, let's take this rose, for example. It has 4 petals. Use your calculator to sort of get yourself oriented. And you know the length of each petal is 3. So I know that the very first point is 0, 3. It might be not 180 negative 3. Then I also can look at the calculator, and at 15, it's like 1.6 or 1.7. It's somewhere between 1 and 2. So one line above and one line below my longest one, oh, I'm sorry, it's 2 lines above and 2 lines below, is going to give me my width. These points are not here, sorry. And then you can follow that pattern. So you know it goes straight up, 3, and then 2 lines between 1 and 2, 2 lines the other way, between 1 and 2, and then it's to the left, 2 lines. So I'm not going calculator point, calculator point. I did that for 3 points, and now I'm just using the pattern that I discovered. And it doesn't matter what pattern you use. I'm sure there's more than just the one I'm using. It's just the one that stuck out to me. For number 20, this is obviously a cardioid. It goes to the right, 4, and it goes up 2, and it goes down 2. If you have a hard time drawing a circle, which is what this is, you should plot some points. So you might have some points around in here to help you sort of get the shape right. And then this last one is a limacon. Due to my inability to plan the graph, I'm giving you a little hint to count by 2s. Otherwise, it really won't fit because you're going 9. And it's going down 9, so I'm going to count by r equals 2. Now, what you have to be careful with is if r equals 2, you can't switch it left to right versus up and down like x and y. It means every circle is 2 in all directions. They're circles after all. So you have to make them evenly spaced out. So it would be here. I am counting by 2s. And so if you count by 2s, that means we'd be left 2. That's really a 4. Right 2, that's also a 4. And this is the part that's difficult. It's not quite 1. So this circle, this inner loop is tiny. And then this is just to kind of want to get your, I always have to plot more points than maybe you would, but I always plot a ton of points so that I can get it drawn on there. There you have it. It's a little bit lopsided. You can laugh at mine because you know I'm going to laugh at yours. And there you have it. There's less questions in this, only 13 on the quiz. Good luck.